Hello, I'm Lewis. I'm going to show you today how to build your very own 3D printable disco helmet using Electromaker's Disco Helmet project kit. It's powered with batteries and controlled by an Arduino Nano. The LEDs at the front are Adafruit NeoPixels, and there is a button on the inside left ear to change the display pattern. If you want to build your own disco helmet, then you can either click this link up here or press the Order Kit button on the Electromaker project page. We'll send you all of these items that you see here. The only thing you need to provide is some filament for your printer and 4 AA rechargeable batteries. On the project page, you'll also find links to the 3D CAD files down at the bottom of the site, along with the code that you need to run on your Arduino Nano for this project. This kit contains 1 meter of Adafruit NeoPixels. This is the type with 60 pixels per meter, and we've chosen to have it on a black flexible PCB. An Arduino Nano to control everything, a sliding switch for the power supply, a momentary switch to toggle the patterns on the LEDs, enough wire to connect everything together, a 4-cell AA battery holder, 1 mini self-adhesive breadboard, and finally 6 LEDs to go inside the ears. The prints for this project are quite large and will take some time to print. I've printed all of mine at layer height of 0.15mm so as to get good detail on the curves. I'd also recommend turning on the brim feature when you slice the models for your 3D printer. This will help increase the surface area of the first layer with the print bed and help stop your prints from becoming unstuck whilst printing. You'll need to print the following: top head right with support, you'll need 1 of these. Top head left, also with supports. Mine took about 19 hours to print. Middle section, mine took 6 hours to print. The mouthpiece, again, this one has supports and mine took 12 hours to print. 2 of the ear extensions, each one took just about 38 minutes for me. A visor, mine took just over 3 hours to print, and I printed this part in black so as to blend in with the back black of the flexible NeoPixel strip. 2 ear covers, these took about 1.5 hours each for me. A battery base, and finally an Arduino Nano cover. As soon as you have some of your pieces printed, you can begin to join them. I'm going to use some super glue to join my pieces together because of its quick drying characteristics and strong hold. You could consider also using some hot melt glue or friction welding, whichever you prefer. If you choose to use super glue like me though, be very careful not to glue your hand to your model. Some of our parts we printed with supports, such as these top parts for the helmet. You'll need to remove these first before we glue them together, and take care to remove them well, as this can affect the final quality of your helmet. I'm going to start by joining the 2 top halves of the helmet together first. I'll show you. Now we can take the middle section of the helmet, remove the support structures and brim, and then we'll attach this to the top 2 pieces that we've just been working on. Now there's just one more piece to glue together before we can start on the electronics. This is the mouthpiece of the helmet. So remove the support structures again and we'll glue it to the base of what we've been working on so far. Now that we have the bulk of our helmet assembled, we can turn our attention to the electronics. You want to unravel the LEDs from their reel, and then we're going to cut them up into 4 equal lengths of 15 LEDs each. I'll step you through that now. So when unraveling this, you're looking to include 15 of these LEDs in each strip. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now when you cut through the strip, you can just use a pair of scissors, but you want to cut right through the center of this strip, right in the middle there. Then we'll count another 15 and repeat the same again. It'd be a good idea to check this length of the one you've already cut. Don't worry if you can see some solder on the joints, you can still cut it, just go straight through the middle again. Check the length again. And then we should be left with 15 on the remaining piece of wire. So let's check that. 14, 15. So there we go. To help make the soldering of these LED strips easier later, we can use the scissors and remove some of this plastic sheathing so we can access these contacts easier. So let's do a couple of snips. Peel back the top. I'll cut that off. There we go. Now we can access this much easier. Repeat this with the 2 strips that have no wires already attached to them. Now we're left with 2 strips that each have some wires on them. One of these sets of wires we don't need, so carefully cut through it. You'll see that just below this glue here, there's another row of contacts. You still want to cut through the middle of those as best as you can. We'll need to keep one of our strips with 3 wires attached on the end that the arrows are heading away from. Double check before you cut any of these wires off. There we go. And again, on the other end, we can expose the contacts. On the strip with the wires still attached, we need to retain 3 of them. What we don't need, and can remove, is the plug at the end and the black wire which was going to it. You see these little arrows? This shows you the direction the data flows. When we attach this to the visor, we want the data to go along this way. Then it's going to double back on itself. So we'll take one of our strips, check the arrows are going in this direction, and come in on that one, along, we'll solder these wires together, travel along this strip, out this side, look at the direction of our arrows, this is fine. So along this one and then back out round here, should we look at our last strip, it's again in that direction. So this is the order and the orientation that you want to glue these to your visor. So now we can attach our 4 strips of 15 NeoPixels to our visor. If you haven't already, tidy up your 3D printed part by removing the brim and any other defects. And then we're going to use some hot melt glue this time, just in the 4 corners here, to hold it into place from inside. This will then allow us to position and glue our strips of NeoPixels to the visor in the correct place. And then for ease, we'll be able to pop out the visor display, including the LED strips, and we'll find soldering much easier this way. So the visor is designed to fit inside the mask with the square hole over here at the top left hand side. We'll put a dab of glue in each of these 4 corners, just enough to hold it for a short while. Now the strip here with the 3 wires still attached wants to come up to this hole. To fit all 4 of these in as well, the top strip wants to be fitted as far up as comfortably possible. Pay attention to the direction of the arrows. They want to go along this way and back on themselves in a zigzag fashion. That's all 4 of our strips glued into place. You can take the 3 wires from the side now and carefully tuck them through this hole. Once complete, you should be able to carefully pop the visor back inside the helmet. Now we have the LEDs correctly positioned on the visor, and we have easy access to the contact pads to solder our rows of LED strips together. So let's start with some soldering. Now you'll need to prepare 9 short lengths of wire, which we'll use to solder the connections where we've cut them on the NeoPixel strips. Now just to remind you, the signal from the Arduino will come in on these wires and then travel back and forth through the NeoPixels in a zigzag fashion like this. Let's prepare the wires and solder it together now. For each of the connections we're going to make, you'll need 3 wires. One about 3.5 centimeters, one 2.5 centimeters, and the other just under 2 centimeters. You'll need to strip the ends of each wire and then bend them into a U shape. We can then solder them to the contacts on the LED strip. So you're about to bear witness to my soldering skills, which are not the best in the world by a very long shot. You may be a more advanced solderer than me, or you might be a complete beginner. Either way, some of this soldering is a little bit fiddly. Keep working at it, persevere, and you will get there in the end. As long as it works, that's fine, and any soldering is good practice. So, let's see what we can achieve. You can see each of our contacts are labelled. We've got ground, digital, and 5 volts. It runs in reverse on the next set. 5 volts, digital in, and ground again. I'm using black wire as it blends in with the rest of the visor. If you've ordered a kit from Electromaker, then you'll have some black wire as well. Before we fit the visor back inside the helmet, we want to extend these 3 wires with 3 lengths of 15 centimeters. In your kit, you'll find black, white, and grey wires. We'll put black to black, white to white, and we'll connect our grey wire to the red wire. Before we glue our visor back inside the rest of our helmet assembly, we'll connect it temporarily to our Arduino Nano and run the code. This way, we can check that all of our NeoPixels and soldering is behaving as we expected. If this is fine, we'll then go ahead and glue it back inside of the helmet. Now, as this is temporary, it doesn't really matter where you put your Arduino Nano. Just make sure that either row of these pins straddle over this line. So the black wire from our visor wants to be connected to ground. The grey wire, which is for our power supply, which will be connected to 5 volts. And then the white wire from our digital in wants to be connected to D6. Connect your Arduino to your computer with a USB cable and open the Arduino IDE. We'll need to install the library extension for Adafruit's NeoPixels first. To do this, from the Sketch menu, go to Include Library and then Manage Libraries. In the search, type NeoPixel. Look for Adafruit NeoPixel by Adafruit and install the latest version. After it's installed, you can click the Close button. You will also need to install the WS2812FX library. There is a link to this library at the top of the code, or you can type in the following URL into your web browser. Once you have downloaded it, extract the files to your IDE's Libraries folder. Download the code for the project if you have not already, and then open it in the Arduino IDE. Ensure you have the board type Arduino Nano selected and the board loader of ATmega 328P old bootloader selected. You can now upload the code to the Arduino Nano, and after a few seconds you should see the LEDs spring into life. Now that we know our NeoPixels are working as we hope, we can glue the visor inside the helmet. Next, we'll turn our attention to adding the LEDs inside of the ear. This is an optional step. If you don't want the ears on your helmet to light up, then you can skip this section. We'll start by trimming the legs of 2 LEDs to about half of their original length. Ensure that the shortest of the 2 legs is still the shortest after you have cut them, by trimming them at an angle. Once you have done this, carefully open the legs before we solder them together. First, solder the negative short legs together. Then, add a third untrimmed LED by soldering its longest positive leg to one of the longer legs on our other 2 LEDs. The negative leg can then be joined to the other 2 negative legs before we solder a 10cm wire to these. And then add a short length of wire to the positive legs. The other end of this short wire is connected to the unconnected positive leg of the other LED. You then need to connect one more 10cm wire to one of the positive legs. You can easily check your LEDs have been connected correctly by connecting the grey wire to 3.3 volts and the black wire to ground on your Arduino Nano, and then connecting the USB cable. Now you've completed 1 ear's worth of LEDs. Repeat the same with the other 3 LEDs, but instead of using 10cm wires, use a couple of 55cm wires. Once this is done and they're tested as well, we can go ahead and add them inside of our helmet. Now the right ear of our helmet, as seen as if you were wearing it, is where the Arduino Nano will be, and so it's going to be where all our wires are going. For this reason, the set of LEDs with the shortest wire will come to the right ear. The others will go over onto the left ear. So let's fix these into place now. Position them as central as you can, and then use plenty of hot melt glue to hold it all into place. You can then take one of your outer ears and one of the ear covers, and we'll fix this in place. Repeat the same steps for the other side of the helmet. Let's extend the two wires on the battery holder. Now we can start to fix some of the wires in place inside the helmet. The first ones we will fix will be coming from this left ear. You want to bend these into place to this corner here and glue them into position. Once that's cooled, you can then continue to bend the wires down into the front of this visor, run them along the underside using dabs of hot melt glue to hold them into position. All of our wires we are bringing to this ear, as this is where our Arduino will be and our breadboard. So now that's our wires from our left ear glued into place, running along the bottom of the visor all the way over here to the right ear. Now we'll fit the base for the battery inside the ear. Apply some hot melt glue liberally around these edges and then place this inside the left ear of the helmet. These wires want to pass through this gap here. We can then take our battery holder, apply some more glue to the reverse. This will then be glued on top of the cover we've just placed inside of the left ear. Make sure when you place it in there though, that the wires leaving it are alongside the ones coming from the LED. We will then repeat the same steps and glue these into position along the bottom of the visor. I would also recommend adding some insulation tape around these joints before we glue this into place. If you'd prefer to follow a wiring diagram, you'll find one linked at the bottom of the page, or you can pause the video now. From now on, when I talk about the positioning of the holes on the breadboard, I will be assuming that you're looking from the top down with the USB port of the Arduino facing left. We need to remove the legs labelled here from your Arduino. I've done this carefully with some wire cutters. You also will need to remove this leg from the momentary button. You'll also need to solder a short 2.5 cm length of wire to the opposite foot to the one you cut off. Also, earlier in this build when we extended the cables to some of our electronic components, I made sure there was plenty enough and that we were not left short. As you connect these various wires to your Arduino Nano, you may find you have some spare cable. Please feel free to shorten the wire before you connect it if you find you have a lot of surplus. First, we'll need to position our Arduino Nano onto the breadboard in the correct place, like this. The easiest way to do this is to ensure that the Arduino's VIN pin is 3 holes up from the bottom and in the 5th hole in from the right hand side. Then everything else will fall into place. I'm going to step you through the rest of the wiring using this diagram. Use a new small length of wire to connect the two sides of the end of the breadboard. With a slightly longer wire, we will connect the Arduino's 5V to the second column in at the top of the breadboard. The sliding switch is positioned so its 3 legs go into the 3rd, 4th and 5th holes along the bottom of the breadboard. Then the push button has the leg adjacent to the cut leg inserted into the hole closest to the Arduino's D2 pin. The wire we soldered to it goes to the far side column. The positive lead from the battery holder is connected to the centre of the switch via the 4th hole in 2 rows up. The negative terminal of the battery holder goes to the bottom right corner. The positive lead provides power for the NeoPixels via the 7th hole up 2 in from the end, whilst the grounding is provided via the 2nd hole up from the bottom right corner, and the data comes via pin D6. Now, moving on to the ears, the negative wire from the left ear goes into the top right hole and the positive to the hole on its left. The positive wire for the right ear goes just below the one for the left ear, and its negative goes just to the right of this. Now we have one final additional length of wire to add between the Arduino's ground pin and any available hole on the rightmost column. Now that you've finished adding all of the wires to the breadboard, you can add 4 AA rechargeable batteries into your battery holder. You can then check that the wiring is working as intended, and if it is, we'll then fix the Arduino Nano and its breadboard into place inside the right ear and add on top of this the cover to tidy away the wires. Here I've stuck down the breadboard using its self-adhesive backing and have applied some additional hot melt glue around the wires to help hold them in place. Thanks for watching the video. I hope you've enjoyed building your own disco helmet, and if you know anybody else who might like to build one, go ahead and share the video with them. If you haven't done so already, you can order a kit with all the electronic components you need to build your own from Electromaker by following the link up here. To be notified when we release our next project, don't forget to subscribe to the channel. Otherwise, until next time, ciao for now.